Algebra 1 EOC Star Review, Category number 5, Writing Exponential Functions. An exponential function is a function in the form of y equals a times b to the power of x. A is a constant, which represents the initial amount. B is the base, which is our growth or decay rate, how much something increases or decreases, and x is the variable in time. Here is a situation exponential that we can solve. An initial population of 5 squirrels increases by 9% each year for 10 years. Using x for years and y for the number of squirrels, write the equation that models the situation, then find the number of squirrels after 10 years. The equation again is y equals a, the initial amount, times b, the growth or decay rate, raised to the x time. Initial population is 5 squirrels, so that is our a value, the starting amount. The second line reads that the population increases by 9%. So our growth rate is 9%, which is written as a decimal as 0.09. So we would add that to 1, giving us a growth rate of 1.09. So y equals 5, the initial amount, times the growth rate of 1.09 raised to the x time in years can be represented, the equation that can represent this situation. The last sentence reads, then find the number of squirrels after 10 years. So now we know the value of x is 10. We want to know what the population of the squirrels will be in 10 years. So we simply substitute 10 in place of x to find that in 10 years, there'll be approximately 12 squirrels. Let's look at another situation. Here, a car is purchased for $34,000 and is expected to lose value or depreciate at a rate of 6% per year. Using x for years and y for the value of the car, write the equation that models the situation. Find the value of the car after 5 years. The equation for this exponential is y equals a, initial amount, times b, the growth or decay rate, raised to the x time. The car was purchased for an initial amount of $34,000, so that is our starting or initial amount A. Our b value, we see that it depreciates or loses a value of 6% per year. We can convert that 6% to a decimal as 0.06, but this time we're going to do 1 minus 0.06 since we are losing or depreciating in value to come up with a decay rate of 0.94. Anytime that we have a value when b is greater than 1, the population is growing, and when it's less than 1, we are decreasing. So in this situation, we are decreasing in value. We're going to use x for the number of years and y for the value of the car. Write an equation that models a situation. So we would say the value of the car y is equal to 34,000, the initial amount, times the decay rate of 0.94 raised to the x time in years. The last sentence reads to find the value of the car after 5 years. So let's let x equal 5, and we will find out the value of the car after 5 years. So 34,000 times 0.94 raised to the 5th power. Now, just a little side note, when we type into our calculator, we have to remember the orders of operations. So I will type in parentheses 0.94 raised to the 5th, get that answer, and then multiply by 34,000. We get an approximate value of $2,495.27. That is how much the car will lose in value.